Raising the hand.
Okay. We're all good.
Am I audible? All right. Yeah. Good morning, everybody. I am Prasad Yalamanchi from Lead Semantics. So you would all know that language and knowledge are two sides of the same coin. So if you find language, for example, it's easy enough to find knowledge somewhere if you're interested in. Yeah. So it turns out there is so much of text, which is a form of language, all around in abundance. And to be able to detect the knowledge in all this text, which is a form of language, you would need some sort of a help from automation because of the sheer size of the amount of text that is lying around. So at Lead Semantics, what we had done is we developed a tool called Text Distill that allows for extracting knowledge from plain narrative text. And we have used Text Distill to extract ESG knowledge from global news, and which is the topic of my talk today. So that is the title of the talk. So it's in three parts. The first part is, we'll talk about what ESG is, a little bit of background and some advocacy. And part two, we'll talk about how we are using the text distill technology to extract ESG knowledge from the news, and then what has been the impact of that. And third part is we would like to show a small demo that hopefully you'll be able to see the extracted knowledge from news articles. Yeah. So it's clear these days that ESG, which stands for environment, social, and governance, is kind of has become prominent, and there is a prevailing understanding that there is a positive correlation between severe climate events and adverse financial impact. On the right hand side of the screen, there is an image that shows major disaster events that have happened in the first 9 months of 2022 last year. And the listed items here are all are $1 billion plus impacts. In fact, at the top there are 20 billion plus and so on. And there are, of course, um, lives lost as well. So it is severe. In that sense, um, ESG has taken prominence from that angle. And clearly, um, the business world has gotten behind this, and then the investment world has gotten behind this. And as Bloomberg projects, there is about $53 trillion, $53 trillion that is under management that is projected to be in 2025, which is roughly about a third of all of assets under management in that same time period. So it is significant. But in order to be able to do successful investing, you would need to have good data and up-to-date and objective data. So the data for this kind of an exercise comes from two main sources. One is the internal company declared data, which is kind of subjective, being that it is coming from the parties themselves. Um, and so in that sense, they're a little bit suspect, of the term that's used is greenwashing in that context. And then there is this other type of data, which is the alternate data, which is news, which tends to be news and social and all those kinds of objective reports, tends to be objective and also actionable in that sense. On the right hand side is a sample of a trusted technology review article that is talking about batteries that in the electronic EV vehicles, which replace solid state batteries with the liquids are switched with solids, and the benefits are obvious in that sense that the range of the vehicles is going to be higher, and they're also likely to be more safer. And the company behind this invention has gone on to raise tons of money. And then there is a company, a major car company, uh, that has already planned to put these new batteries in their production line in 2025. And this information is extremely actionable, and it would be timely if someone wanted to act on it, and it is in a very trusted article. So for some of this information to make it through your quarterly reports and things like that, it would have been stale by the time somebody gets a hold of it. So this alternate data, it tends to be extremely interesting and useful. And text is a major part of this alternate data. And because of the abundance of this data that is available, you would need the help of automation to deal with this. And text, as we said, is a different carrier. It actually carries knowledge, unlike other sources of data, like data that is in relational databases and so on. It is not completely knowledge yet. Whereas text, because of the context in which it is actually laying out the facts and such, you have all the information necessary to rebuild the knowledge that the originator has intended. Unlike the other sources. So it is pretty valuable. And it is actionable, and it is timely as well in the case of news. On the right-hand side, as you see the article, um, the highlighted terms in different colors are the elements of what makes up the facts that could be interrelated to give you the sense of the original knowledge. And this is all in one single article. Um, and so tapping this knowledge at the source, which is this article, would give you undistorted information, versus if you waited it to go through other workflows before it ends up in different forms of data storages and things like that. Somebody has to reconstruct the whole thing, and the fidelity of the workflows would have to be tested as well. But knowledge extraction from text is a notoriously hard problem. But then, luckily, in the last few years, the technology has evolved to a point where that has become, practical and real. And knowledge extracted from this way can be added to knowledge graphs, and that's how it becomes pretty relevant for us all to discuss. Knowledge graph give you a different type of analytics, given that they are holding knowledge directly. Knowledge is a user level abstraction that users can interact. The stakeholders can directly interact without any distortion. And knowledge graphs are also pretty dynamic in the sense that changes in the underlying schema of how these facts and the data elements get organized and interconnected. If they change, the graph structure is pretty fluid in terms of capturing that. So it's very easy than other modes of storage. And in the case of sustainability and ESG, given that it is a highly dynamic field and a vast field at that, and it is changing all the time, knowledge graphs become an important artifact to kind of, make their play in this case. And knowledge graphs also tend to integrate different data types and data sources. In that sense, they have the potential to break down silos and give you that visibility in your decision environment, kind of de-risk the environment, so to speak. Other technical benefits are with the knowledge graphs are you're able to build um, sophisticated applications, given that it is a lot easier to build these applications off of a graph than other technologies. And it also allows you to do graph analytics, which are a high value analytics directly, given that it is a graph structure underneath. And additionally, it also gives you search. Graph-based search is verifiable, which hopefully I'll be able to show you a full play here. Unlike other searches, graph-based search tends to be very tractable. It connects to the source and things like that. And then the next level of benefit is reasoning, which is like, giving you a chance to generate new facts out of the existing facts that you have, and they tend to be all pretty consistent and so on. So the text distill, as I mentioned, is the tool that we have used to extract this knowledge from news. The architecture, briefly, is that it takes in text as documents on one side, it puts it through various pipeline stages, it applies all kinds of machine learning models and things like that to capture the concepts that are relevant to the problem area that you're dealing with. So you would train these models specifically to those concepts, and so they would get deployed in this pipeline. And then, of course, we interact with the schema, in this case, an ontology for ESG, to be able to understand the text that you are feeding in. And so you are actually letting the pipeline understand what is mentioned in the text. And then out comes the facts in the form of RDF, which is a standard W3C format that you can directly load into any of these standard triple stores, so-called knowledge graphs. And knowledge graph, as I said, enables a powerful search. And when I say powerful, I mean I'm comparing it with other modes of searches that we know of, including the recent searches that are based on embeddings and so on. Unlike that, graph in the middle, graph is literally reflecting the facts that are extracted from the text, and the graph is also enabling the natural language interface. And so it acts as a mediator, and it connects the exact phrases and clauses that are feeding into the answers that provide your final answer to the question you asked. So in that sense, in the illustration that you see, a very high level string query is entered here, like show Nestle climate claims through partnerships, and then it gives you among many summaries as answers, one of which is highlighted here. The answer is made up from two underlying documents, and these two underlying documents have two separate snippets of text that is feeding into the answer. And so it is able to pull all of those things in a visual manner, so that it gives you instant verifiability, and we'll see that in action a little later. So we have used, as I said, this text distill extracting ESG knowledge from global news, and the global news is from Factiva News Service. And this service is now available on a subscription basis for those that want it. The way it is done is the configuring the text distill pipeline itself involves honing in on the specific ontology. Ontology for ESG is pretty vast, and we are no masters of ESG yet. And so we pick and choose the kind of corpus that we are dealing with, the kind of news articles that we are dealing with in any one session of our text distill run, and then organize our ontology, the concepts that we think we are going to encounter in the text. So we organize the extraction graph, which would be the subset of the overall ontology that we would be interested in. So we can integrate later on into a knowledge graph, a full-fledged enterprise knowledge graph for climate, for example. And then clearly the concepts themselves they kind of, have their own taxonomies, and then the vocabularies and things like that. So there is a whole bunch of back-end activity that goes on to lay out all the kinds of ways that these things get detected in running text. And then the input itself is a text, as I said, and the output is RDF, resource definition framework, the W3C standard, NQuads in this case. We can also output JSON files, but our preference is RDF to begin with by default. So it goes into an RDF triple store, the outputs. Yeah, so that is how you configure the text distill run. And the impact of the work is that, as I mentioned, once the facts are extracted from the corpus and they go into the knowledge graph, they are completely verifiable. I mean, in the sense that, all the search strings that you give in would produce the answers if it can find any answers in the corpus. And then in the corpus, you are able to click on things that you are interested in, and they get linked back to the phrases and clauses in the underlying text. So the verifiability will be absolute in that sense. And so that would lead to decision making that is probably much more transparent. It gives you a chance to do deeper analysis because it's a graph based. The interlinking will give you a lot more visibility into all the connected elements of the source data. It gives you two very high level workflows. One is the search, as I said, and the second thing is the extracted facts themselves can go into an enterprise knowledge graph once you kind of integrate with an upper level ontology. Yeah. And I will quickly go into the demo, if you will. I think that will probably put everything in perspective for you all. So I'll just click it here. So I have gone to this external internet website, textdistill.ai. I'm logging in. Give myself and here you will see, in the interface, you're able to load in files, load in web links from the sites itself. Um, for now, I will upload a couple of files from my desktop. These are, plain text files. And then see, we have configured the minimal climate ontology. Enough to be able to extract organizations and enough to see any relationships between organizations, and then any organizations that are making any claims in the green variable space, like carbon emissions and things like that. So that is a minimal ontology that we are trying to load. So I'll try to quickly go and maybe pick up a couple of files here. So I'm loading these two files from my desktop. So it says it has loaded two files. And then it pulls up, different organizations that it had found in the files that you had loaded. And so I'm selecting EIB is a company. And then, so when I click on the EIB company, it has identified, the query that we have configured for this demo is, company A, the company that you have chosen, if it had any relationship with any other organization, and then this other organization B, let's call that, B has made any claims in the space of green variables, saying like, maybe it is a greenhouse gas emissions, and they are claiming that it would be reduced by 20% by 2030 and so on. So that is the signal that we are looking for in this. And so by clicking on this company, we have just produced this result. The system has produced these results, and we can double click. So this is an answer that it had produced from the underlying documents, the two documents that we had loaded. And you can read the summary. In this case, for example, the second summary here, European Investment Bank invests in EA, so all of this you can read, and you can figure that there is something related to renewable energy sector, and so on and so forth. If you are interested in seeing how this summary was made up, you can double click on this, and it would produce the underlying graph of these facts from the underlying documents. We had two documents. These two documents are showing up here, and then you can click on any one of these things and see, the highlighted text is what is contributing to the nodes and, these edges. I can bring up the edge labels as well. So this is the instant verifiability part that I was talking about. So you can see the summary being generated for the question, which is company A investing in company B, or having a business relationship with company B, and company B making claims about some green variable. That is the minimum ontology that we had set up. And then a signal that we are looking for. It has produced various summaries. I have clicked on one. You can see this, and you can verify these things if you are able to read through this. One second, I'll clear the selections, bring up the edge labels. And you can click around and, for example, here, this is a green variable claim by EIB in here. This is the European Investment Bank, that has a business relationship with Toivo Group. So we can check to see is that where it is coming from. See, in this case, Toivo Group receives, some money from EIB. So, and that's how it is. I mean, so you ask a general question, it brings up all the answers from underlying documents, wherever they may be, from snippets of text. And then you are able to actually verify is the underlying text providing the real facts right then and there. And you can go back to check all these other summaries as well. So each one of these things is giving you, different answer. For now, what I will do is I will try to upload something from the web. We generally go to ESG Today, ESG News. We can pick up some, this is ESG Today. So I'm looking at this Honeywell. Honeywell launches technology to convert CO2 to sustainable aviation fuel. So there is something related to green variable information. So hopefully we will see if we are able to see that. I'm dropping that link here and I'm submitting that to the software. Did it detect any? Yeah, it has detected these various organizations, and we can click on this. And so it has produced some summaries. Again, the signal that we are looking for is, in this case, Honeywell, does it have a relationship with some other company, and this other company, or Honeywell, did it make any green variable related claims? In this case, it's coming from a single file. And we can again check to see, so in this, there is a green variable here, and then there is a business arrangement. This icon is showing business arrangement. Oops, 1 second. I'll click on this. So it is saying HIF USA, Honeywell, and HIF Global together recycle CO2. So all of those elements are here. And so you can instantly visually verify whether this is, coming from the right text piece, and, so on. And as I said, there are other summaries as well that fit the signal that we are asking for. So that is in a nutshell, how the text itself. We have the corpus interface also here. So we can go into the corpus, and I think we loaded about 150 files in here. And again, the same signal is what we are looking for. And corpus itself has many companies that already are in place. If I can remember a company name, I think Pepsi was here. PepsiCo, maybe EIN. Or UBS, I think. Yeah, I kind of remember this company here. And this is in the corpus. So again, for that signal, it has produced, so different summaries as answers. And you can again go back and check. These two colors are saying that, these are two documents that are producing the underlying answer. And you can also go back to check to see that is just the answer for the question that you have asked as part of the search. But you can go into a larger part of the corpus and search the same thing and see if there is more to this in the knowledge graph. And it is pulling up all the different predicates, and so there would be a bigger knowledge. So UBS as a company was found in these multiple documents, and there was more knowledge that was pulled up. But as part of the search for that specific signal and that one single summary, you had a different interface that allows you to just search and visually verify for it. So that's where I would stop. And if you have any questions, I'm ready to take. Thank you.
You can just speak up there. See that.
Yeah.
But the other people online will want this.
Yeah, but they can hear it too. But the microphone's better. Yeah.
So it's 2023, so no talk can possibly go to the end without somebody saying Chat GPT. So
Yes.
I've seen lots of experiments where people have taken bits of natural language, thrown it at Chat GPT and said, give me RDF out of it. Sometimes it's horrible, sometimes it's miraculous.
Yeah.
You've got something that's highly controlled. We know exactly how miraculous and how horrible this is. It's actually pretty definitely on the miraculous side, so that's good. Have you done the experiment of taking the same thing, go to ChatGPT, compare them head to head, and say what you're doing better, what ChatGPT is doing better, and so on?
Yeah, wonderful question, and very timely question, right? So what would be interesting is that we are actually using ChatGPT 3.5 as part of our interface.
Okay.
So we are using semantics to drive ChatGPT.
Oh, that's pretty cool.
That's one of the reasons why we get a highly, accurate.
How are you doing that? How do you get your ontology into the prompt, or how does 3.5 understand your ontology then?
So we are generating the prompts on the fly, and that's one of our magic sauces.
But the ontology is probably too big for the prompt. You take pieces of the ontology.
Exactly. Based on the context, and based on, as I said, we have configured this demo for a specific signal, which had,
That makes the ontology smaller. Yeah. I've tried that for Fibo, but Fibo has 316 ontologies in it. It's enormous.
Absolutely.
There's this huge prompt engineering problem that you can't even get out of the starting
But then, given the corpus, I mean, if you can limit the different types of concepts that may be expected to be found in the corpus that you're looking at.
I haven't been successful with that. That's because Fibo is such a...
You can give some sample documents like, Chat GPT or something to kind of reduce the concepts, or even, concepts that you're likely to find.
I just haven't got that to work yet, okay? I mean, you have, that's great.
Yeah. So we are actually using Chat GPT 3.5, but the one interesting thing and very contextual for us in this conference is that semantics is driving GPT. Yeah. And that's one of the best ways to kind of, make these two work together. And that's what gets us the automation, all the way till the end. Yeah.
I'd love to hear how you see this capability being input to a more persistent graph, and how you would kind of handle the temporal nature of news changing so rapidly. Like what is the ideal state for this really building a persistent and evolving graph?
Yeah, very good question. As you rightly said, off of news, I mean, there is a whole bunch of curation process that you would have to, plan out to feed this into an enterprise knowledge graph, for example. For example, the ontology that we use is a very shallow ontology. And before it can be plugged into an enterprise knowledge graph, you would need to overlay an upper ontology that kind of, makes it federatable with the actual knowledge graph at the end. And then in the process, the concepts and, the various mentions, even as you see in the demo, many of them have been collapsed with a local linking database, if you will. And so for any given session, you will not be able to plan out an intermediate reconciling databases that will, that will be accurate for your ultimate, endpoint. And so there is a lot of curation plans that you need to do. But these are methodically that you can, systematically you can arrange for that to happen. Yeah. Thank you.
What is a level of abstraction of the knowledge that is extracted? For instance, encyclopedic knowledge is pretty simple usually because if you have to extract something like, I don't know, Washington's capital of the United States, it's very easy. But what about relationships that are as complex as the ones that have been shown? Is RDF enough for that?
Well, I mean, RDF, we have not encountered the outer bounds of what can be put into RDF. Let me put it that way, because ultimately these are concepts and predicates, and at some point you would have to, I guess, the predicates you'll have to settle for the predicates that make sense for you, for the context. And in the process, it could be that you are missing out on some explainability at the end, but it works in terms of where the source data is. I mean, you're looking at a source piece of text, and did we extract the information that you would have normally wanted to as a person, for example? And so you would settle for it in terms of what you have organized in your ontology in terms of the predicates, the hierarchy of predicates. And so one of them will become the class that kind of actually captures what is in the text of the of the article, for example. Yeah, did that answer? Yeah. Thank you.
I think that's going to be about it. It's lunchtime for everyone.
Thank you so much. Yeah, appreciate it. I know we can chat. I mean, I have my LinkedIn. If you all want to connect, we can also chat here. Thank you.
Hey, good to see you. Yeah. You're first up tomorrow. I know. Well, everybody gets there.